Hello and welcome to Let's Build Multirotors. My name is Dillon Carpenter and I'm the AMA's Digital Experience Lead. I'm also the executive producer of AMA Air, so if you're a regular listener for AMA Air, I'm the guy behind the scenes supporting Matt and Claire, pushing all the buttons and helping them look the best they can and help them plan the show out. So today I'm going to be building a ReadymadeRC Strix Screech frame. As you can see here, I've got my nifty little overhead camera. So hopefully by the end of this series, this is going to be a complete drone. I'm kind of treating this as a beginner stream. So as I go, I'm going to try to narrate exactly what I'm doing, why I'm doing it, hopefully give you some what I hope to be tips and tricks about how I like to build. This isn't going to be a definitive end-all be-all for how to build multirotors, but I hope it'll at least show a different perspective about how I like to build them. So I want to start off by saying, despite all of the ReadymadeRC branding in here, we are not actually, this stream is not sponsored by ReadymadeRC. This is just my personal build mat. I actually won it at the Tiny Whoop museum flight, and this Strix frame was provided to me as a review. So I had this all built full of ReadymadeRC components maybe 2 years ago, a year ago, and this was a review unit supplied from ReadymadeRC and included, I believe, the Cricket Pro V2 here, as well as this Strix Hoot antenna. I'm going to be running a FrSky receiver on this. Yep. So there's the review you can see up on your screen. You can check that out at modelaviation.com. There's a video to go along with that of me trying to fly a multirotor to some music. But as you can see, we've already built the frame. If you want to learn more about how I felt the frame went together, definitely check out that review. But we have the Cricket Pro V2 for our video system, Foxeer Aero Pro. So this has an OSD because this RaceFlight board does not have an onboard OSD. This is the Revolt V2, was before they put OSD on there. So we definitely need our voltage through our camera so we don't run our battery dry. And this is the iFlight SucceX-E 45 amp 4-in-1 ESC that we're going to be putting on there. So hopefully, these DYS Samguk racing, I think they're 2600, 2700 kV, 2206, 2700 kV motors. And I got these for a really good deal. And I kind of like the blue. So without further ado, let's go ahead and begin here. Basically, the first step that I always like to do with a build is to kind of test fit all of the parts together. So I'm going to go ahead and take off this top plate here, off the Screech. And we're going to see if everything fits on there. So this does a couple of things. This lets you know whether all of your parts will fit, and kind of give you a little insight to your build about how you might want to go about it. You know, if a certain area is going to be kind of tricky to build around, this will definitely give you a heads up. So when you get there, you know different ways to kind of get around that. This is a nifty little tool that I got from Quadbox. It's a 2mm little nut driver here that I always keep a 2mm, I keep a 1.5, and I keep a 2.5mm in my little bag, because those are kind of the most used ones that I use here. Okay, so I'm going to go ahead and start by, let's disconnect these guys here. Put this, I think we're going to have these leads, because this is where our battery leads are going to come off of here, off to the side. I think that'll be a good place to have those go. That's going to fit pretty well. And then usually with these flight controllers with these little gummies, they just sit in there, so you don't have to crank them down. I might put a nut on top of that just so it don't fly off or something, but I think that's actually going to be pretty darn good there. So I don't know if you can see this, but there is a little connector here that is preventing this from going all the way down. It's kind of making it sit a little lopsided on there. So I might have to find a different way to put that on there. I might be able to put some nuts down there on the between the stacks to kind of separate those a little bit, but I feel like that's going to look pretty good. We definitely have some space to build. You know, if you see here with the top plate, we have some space to build on top of that, so we definitely have some room to go up if we need to put longer screws on there. So that's going to be good. Of course, a big thing you want to double check is whether your motor wires are long enough. And I think these are going to be long enough for sure. Yeah, so that goes all the way over there. And all these motor wires are the same length. We'll probably have to trim some of those off. If you did have shorter motor wires, like I've got some here that came off a build with ESCs that go on the arm. Now, obviously, if I was using these, they wouldn't make it. But they have these nifty little plates called race wire that you can get to kind of bridge that gap. And they're just a flat piece of circuit board that you can put on here to kind of bridge the gap. So if you're running into that problem, there is a solution. And then I'm pretty sure this is the camera I was running on it when I did the review, so I think that's going to fit in there nicely. Yeah. So for the bigger cameras, it kind of has this little cutout that it sits down in to give some more space. And then, let's see here. I think last time I fit this, this was kind of my problem area, was this rather large VTX. What I think I ended up doing was I think I put it on the top plate, then ran it out the back, kind of like that. And the thing about these Cricket V2s is you've got a couple of buttons here. This is nice on the race course because when you power up, your VTX doesn't turn on. So if you're on the wrong channel or something like that, or power up accidentally for whatever reason, it's not going to blow everyone else out. It powers up in race or in pit mode. But the thing is, you have to press the button, so you have to make sure that these buttons are accessible. So if you bury it under the frame, it's not really going to be too good for you. But yeah, I think we're going to have a pretty easy build here. Hopefully, I don't eat my words later, because that can probably just go somewhere up here when we put it in there. But yeah, so what I'll go ahead and do is start wiring up the motors to the ESC. So you've got pads all down here in your motors. This is going to be so it's labeled here. I don't know if you can see it. If we had the pin out, we can pull that up, but you got motor 4, 2, 3, and 1. Yep. So that's how you're going to wire these up. So you can see right there that each of your motors are going to go to each of those things. And if you have to turn the ESC a certain way, there's a way to fix that in Betaflight so that you don't have to deal with that, which I might have to do since I'm putting the motors out the side. So what I'm going to go ahead and do is just wire them up where they fit, because really this is made to be put in here, because you've got motors going. This is the front of the drone. 1, 2, 3, 4 is usually how Betaflight is laid out, and that's how these motors are: 1, 2, 3, 4. So if I go turning it like this, then we've got motor 1, 2, 3, 4, and that's gonna cause some problems if we don't remember that when we look in the software. So first, what you want to do before you start doing any soldering, I usually like to tin these pads with solder, so you get a nice surface to. Let me go ahead and warm up my iron here. It gives you a nice surface to be able to stick the motor wires to. And I've got this nice little helper here. It's got a magnifying glass on it and a couple of alligator clips so that you can hold what you're working on in place. So I'll go ahead and raise this up just a little bit so you guys might be able to see what I'm working on better. So what I do when I'm tinning is I get just a little bit of flux, and I've got my solder here, and I'm going to go through and just put a dab of flux on each of these pads here, just to kind of help the solder flow onto the pad. Because we don't want to stay on there too long with the soldering iron, or we will burn that pad off and cause it not to be able to connect. You know, burn the circuit board up, so that the traces, there's little tiny traces in the circuit board that are going to these components, and if we burn those up, then pretty much just have to buy a whole new piece. So that's not what we want to do. We want to be able to get in here as quick as we can, touch on there, have the solder flow out, and be done. So I'm just putting just a little smear of flux on each of these pads, and I'll go ahead and tin the power terminals as well while I'm at it. A little bit more on those. All right. So you're going to take your soldering iron here. So I don't know if you'll be able to see the flux. That's kind of just a little bit on there. But what I'm going to do is just tap that here, clean off my iron. Got a little metal sponge that I clean off on. Put the iron on the pad. Just touch the solder on there. And it should just flow out on the pad. And you're looking for a nice smooth solder flow on that pad, so you can see it's very shiny. We want to make sure that it makes good contact. You don't have a cold solder joint, which happens when the pad isn't heated up and the solder is just flowed on a cold pad. That doesn't make a very good connection. In my experience, that's the positive terminal there. In my experience, the ground takes a little bit more heat, so you want to make sure that's nice and heated up, because you want that nice bubble after you lift up your solder on that pad. So those might be a little bit easier to see on the overhead camera, how they're kind of nice and smooth, just a little bubble of solder right there. Another piece of solder. So I've got a whole roll of solder, and I just kind of cut off a length, and once I get down to the end, I just take off another piece. So we'll finish up tinning these pads. Does anyone else have a project they're working on? Wattage recommending for a soldering iron. That is a good question. What I'm currently using, let's see if I have a wattage here. I'll just show you my soldering iron. I've got a station here, and it's an Xtronic model 3020. And I'm running at about 730 degrees, and it's actually going into sleep mode. It's a nice little feature that it has. You can see it counting down. But I run at about 730 degrees Fahrenheit. If this negative pad here was really sucking the heat in, I might turn it up to 800 degrees just to make sure I get that pad nice and hot. Go ahead and clean my tip off, because we don't want that oxidizing on there and ruining our soldering tip. All right, so you can see that is fully tinned. All of those pads. If I do say so myself, that's not a bad little tin job. I kind of had a realization. I was running this with the pads up before, but if I flip it over, which will probably screw up my motor assignments even more, this little pin connector here is now sticking up. So I think it'll kind of offset the pin connector on the flight controller. And so they'll sit nice and flush on there. Yeah, and that's exactly what happened. So before it was kind of all, I still might put some nuts in there because you can't really see it. There's a little bit of a gap between the boards. But now it's sitting nice and straight on there. So I think that's what I'm going to do. Which works because that's going to make our motor wires look really nice. And I'll show you how I'm going to do that here in a second when I get this pulled off. So a lot of times I'll go ahead and put my motors right on there. So I'll grab my 2mm hex driver here, and I've got a whole box of different parts and stuff over here. I'll show you. Got a lot of little storage and things. So I've got my extra nuts and parts and stuff like that just right here. I'm going to grab out. So I can get some nuts for those here. So another good point that I want to make is carbon fiber is conductive. So if it's going to short out if you have a few pieces touching each other on there. So I'm going to go ahead and finish putting my motors on here. Now I usually only put 2 screws in each motor. That's usually enough to hold it on there in my experience. The racers will say it saves weight, but I don't know how much weight 2 little screws is gonna. I mean, maybe if you're chasing like hundredths of a second or something like that, that might come into play. But these might be racing motors, but this is going to be a freestyle drone. I'm more of a freestyle guy myself, but these motors were just too good of a deal to pass up when they came on sale. So I'm gonna have a fast freestyle drone. That's how I'm gonna think about it. You might be asking, I don't see we have any questions. You might be asking, what's the difference between a freestyle and a race drone? Or race drone seems pretty self-explanatory, but what is a freestyle drone? And you can kind of think of those guys as the skateboarders of the drone racing community. So they like to go out to parks and different spots that they can fly in and use the terrain and the surrounding, features of the park, the flying field, to make art. Use a Weller 15-watt on circuit boards. So to answer Chris's earlier question, we had Steven chime in on YouTube that he uses a 15-watt soldering iron on circuit boards. So that's a good little tip there. I'm going to go ahead and tin these back pads too, now that we're going to flip this over. Again, we're just putting a little flux on there to help the solder flow, applying heat to the pad, and introducing solder. So we get that nice little bubble. Oop, it's all going to the back side, isn't it? Anyway, that's tinned and ready for our power leads when we get there. This might not work, but this is what I'm going to try. This is how builds go. So what I want to do to make this a nice and clean build is to actually take these motor wires and bring them around underneath, kind of like this. Oops. Take them all, bring them around underneath, and hook them in like that, so that all of these motor wires will actually be hidden underneath the ESC. So you can see how clean that looks. Imagine these aren't here because they're soldered to the pads. So that's brought in under there, and we've got like a little zip tie or something that we can put here, and that just makes it really nice and clean, so you don't see those solder spots. So let's go ahead and try to do that. The next thing you need to be looking for is how long these motor wires need to be, because you don't want to cut them too short because you'll be left in a bad way. So I just kind of eyeball it, really. They might get cut a little longer. I don't want to cut them too tight, too close to the to where they need to be, because that won't leave me any wiggle room. So looks like about right there. And what I'll do is I'll just take my X-Acto knife. Got a real sharp hobby knife here. What I'll do is just make a cut right there where I've got my finger, so I know how long to make, how long to make each of the motor wires. Because you can't cut them all straight across. If you cut them all straight across, then they won't line up very well. So I'm just going to make a little nick in each of the wires here, so I know how long that specific run of motor wires be. So you can see I cut them all straight across. That's probably a little bit too small for you guys to see here. Cut them all straight across, but the actual nicks are kind of in a sloping pattern. So that's why you don't want to cut them all straight across, because of course the farther one in is going to have a longer wire. So I'm going to go ahead and just nip those right there at the little marks I made. And I'm going to save that wire for later. I don't usually make a habit of throwing away these wires because they come in handy later on. Sometimes you need just a little run. These are perfect. Like if we were putting on those motors that I had earlier and needed to use one of the race wires, you can take these from the ESC to the race wire, and those are the perfect length. So I don't like to throw away these little bits here. I like to keep those. But with the rest of these, what we're going to do is nip just the little last bit off of there, and I just take my thumbnail and I kind of just cut off just the last bit. You can see that silver here right at the end, just a little nip off there, just enough to stick out so you can put some solder on it and tack it down to that pad. So you can see there just a little bit off the end. Now what I'm going to do with these is I'm going to tin these as well. So I like to stick a little flux on the end there, and I just kind of dab my flux into the wire, and then take a little bit of solder, touch the tip to the wire, and then add the solder. And the solder just kind of flows down the wire and makes a little bulb of solder down at the end. And so if you might be able to see that, the end of these are just barely soldered, just enough to be able to grab enough on there. So I'm going to go ahead and repeat that for the remaining motor wires. What solder do you recommend, Quinny Perks? That is a great question. I usually use a 60-40 blend. This is what I'm using right now. Let's see if it actually says. This is 6337 actually. So I went back on that. So 60-40, any of that lead to silver or that kind of radio. This is for lead core solder, Studio Pro. But that's the solder I'm currently using. But you definitely want a little bit of acid core in there. Like I said at the beginning of this, I'm not purporting to be a soldering expert, but these are just my my views and how I do it. So there's, I'm sure, a better way to do a lot of the things I'm doing, but this is just how I do it. So when we're actually soldering these two together, this should be pretty easy since we already have both of them. We shouldn't even need to add any more solder now that these are both well tinned, because the solder from the wire should just go ahead and melt into the solder on the pad, and we should be good to go. So I'm going to head, what I'm going to do is use this other arm just to kind of trap that down. At the position that I want it to be. Just kind of holding it in here. I know I'll bring that up so you can see it. So I've just used that alligator clip just to kind of trap this alligator clip here, just to kind of trap that wire down. And then this other clip is just holding the board. But I'm trapping that wire so that I can have a helping hand to solder it. So all I should have to do on this is just tack that down, and that both sides of solder, make sure that melts, and make sure again it makes a nice round connection so that both kind of just flow into each other. So I'll bring that up a little bit. Like I said, I'm sorry guys, I know it's a little hard to see, but you can see it's just kind of a little blob of solder right on there. I'm going to continue on down the line here. So yeah, it's going to go right around there. I can take my motor off to give myself a little slack to mount this to get the wires exactly where I want to go. But that's going to be nice and tacked down. And the wires are going to go right behind that chip. And that's what it's going to look like when it's done. So we'll put a zip tie or something here to kind of hold them in place. But that's going to look nice. When all four of them are going in there, it's going to be a nice clean build. Get these little scraps out of the way. Like I said, I don't like to... I've actually got these little boxes that I use for scraps of wire.
And here's where I keep assorted lengths of wire. Whoa.
And originally, they are motor boxes. So I think these are like Emax motors that usually come in these. But they're nice. They've got this little clip. Like I said, I don't like to throw stuff away. They've got that clip, and then I've just got a bundle of extra wire that I've done. So that'll just go right in the cache of wire. It's all just kind of free extras. You know, I've got some lead wire that I use. You know, when I retire batteries, I cut the leads off and I put them in here, and those are great for. We'll use that for the main power here. I've also got an entire box of red stuff, and I've got a bunch of little parts, just kind of bits and bobs in these little motor boxes. And those are really nice. So the longest one goes towards the inside, shortest one to the outside, just like last time. So I went ahead and completed installing the motor wires to the flight controller, and then, like I said, I've tied them off with this nice mesh, and then I've left a couple of zip ties hanging out here. And when we get to the receiver portion, you'll see why I've done that. But I've got zip ties on each four of the corners here, just to kind of make them nice and neat. And I'll zoom in here so you guys can see just how neat this build looks with those wires running underneath the ESC. I think it looks really nice that way. You'll notice a red mark. I've got a red mark here. I've also got a couple red marks here on the flight controller here. And that corresponds to which side this little ribbon runs on. So the way the flight controller attaches to the ESC, you use this little piece of wiring harness here, and a lot of times they come wired just straight through. So the first pin on this would correspond to the first pin on this. Now that's great if you've got a stack that you've purchased that is going together, but these two have completely different wiring schemes. So you got to make sure you notice that, and you'll see I've got different wires going to different places, and I went ahead and pre-wired this just so you wouldn't have to sit here and watch me take little individual pins out. But basically how I did that was I got in here to these little grooves, and I've taken a pin and taken each of these out separately and then moved them to the corresponding location on here. So you can see on these stacks here that there are, let me see if I can get in here real nice and close. There are different markings here that say what each of these are. So it looks like it goes telemetry, current monitoring, motors 4, 3, 2, 1, and then I think that is battery and then ground on the flight control on the ESC. And then on the flight controller, you can see where if I put it the same way, so we can kind of compare them, you've got a completely different wiring order. So you've got batteries all the way over here, current monitoring, ground. Then there's a 5-volt BEC on this one that is really nice to power your 5-volt electronics. And then you go, looks like in reverse or in proper order, 1, 2, 3, 4 with your motors. So if I would have connected that directly to the ESC, I would have completely toasted this flight controller. So that's something that you definitely want to double check. Always double check, especially your positive and negative leads when you get into wiring like this, because I have scrapped so many electronics just from messing that up. So we'll go ahead and get started here as I refocus my overhead. But this is going to be fairly simple. So I take my, I wanted to make sure, like I said, to have those marks there. So I do my 2 marks, and that lines up here. So I know that's the end I meant to go in the flight controller. And then I do the one with 1 mark here, because that's the one that I know was meant to go on the speed controller. That'll fit in just like so. And then you want to make sure that your board direction is facing forward. That's not a huge deal. You can fix that in software, but it's just easier if you mess that up. Another thing that you might take note of is where your USB plug-in is on your flight controller. So if you were to mount this, let's say in this fashion, for whatever reason, you'd have to come in all the way through the, if you have your top plate on here, that's going to be really hard to access. You'd have to come all the way in through here and get your fingers down in there and try to plug it in here. So it's a lot easier. I've seen some boards that actually have it set up with the USB on the back, and I always rotate those. But that goes on just nice and neatly right there. And you can see I've also put a couple of nuts right in here, some plastic nuts to kind of give a little bit of bushing from the ESC to the flight controller. So the flight controllers with these little bobbins here, these little gummies, they like to call them, those are not meant to be screwed down. They kind of float, so the flight controller dampens any vibrations that might confuse the software. And if I hadn't put this little nut, this little plastic nut in here, these wiring harness connectors would have touched, and it would have, you can kind of see there's not very much clearance. There's just enough clearance with those little nuts. So that is definitely a little tip that went into this build specifically. So get refocused here. So that is pretty much the connection of the flight controller to the ESC. Now, I did some behind the scenes work, as you saw, just to make that a little bit easier for us. But I hope I explained it clearly enough. If anyone has any questions over what I've done here, if I didn't explain something thoroughly enough, or I was a little confusing on some part, please feel free to mention it in the comments. I would love to answer your questions over why I did something a certain way, or if you guys even have maybe a better way of doing it, I could do that. From my test fit of the video system, I found that I think where I want to install this is actually on the underside of this this plate here. Because with these buttons, you want to make sure you can get to these buttons. Since this is the Cricket Pro, you actually have to turn on the VTX before you fly. It starts up automatically in pit mode. So if you're racing, you don't blow out the entire line of people racing if you accidentally plug in or need to plug in for whatever reason while there are people racing. So I think what I'm going to do, maybe that's how I wanted to do it. Like that. Yeah. Yeah, I think that must be how I did it. What I'm going to do is I'm going to get a little bit of piece of this Gorilla tape. This is Gorilla double-sided tape. Try double-sided tape after heat shrinking the VTX. Yeah, the problem with heat shrinking the VTX is you have to have access to these buttons here, for sure. And I just, if you heat shrink all of it, it is actually, there is a clear layer of heat shrink on it already. So you can see, I don't know if you can tell that, but you can kind of see it's glossy. There is heat shrink on it already. But these buttons, you definitely have to have access to these buttons, especially since I won't have smart audio with this flight controller that I'm using. So definitely use double-sided tape though, for sure. I'm really big fan of this Gorilla tape. So I'm going to get some of this Gorilla tape. I'm going to get out my hobby knife here. Couldn't find it last time. I've got it here this time. And I've got my my kit of tools here while I have this out. And it's actually, don't tell anybody else, it's a makeup bag. It's Flirt. I just had this laying around. My wife probably had it. So I've got a bunch of different stuff here, a portable soldering iron. I've got all of my different pliers and stuff. I've got a Leatherman, some extra solder, solder sucker. It's all on this side, which is my bigger stuff. And then I've got my various drivers and screwdrivers here on this side, and a pin and a Sharpie. That usually comes in handy on that side. And that's a really cool little bag that I can just stick in my flight bag, and I have my entire, I can repair an entire drone with that, especially with that battery powered soldering iron in there. That's really nice. So what I'm going to do is take this double-sided tape. We'll go ahead and just stick some right here. I'll get about how far I need to cut into it. Cut on my nifty little mat here. So I'm not cutting up my table. Stick that right on the back. And this Gorilla Glue is amazing. You don't even need to zip tie it down, or Gorilla Tape. You don't need to zip tie it down or anything, because it actually has some pretty good staying power. So how I'm going to strap this on here is to have the pigtail on the back, or the VTX pigtail on the back, and then the connector on the front. Just kind of stick it right here in between those guys there. And I've got a little bag of zip ties off to the side here. I'm just going to zip tie that guy down. Taking care to miss those buttons so I don't have one button always pressed down. This just gives me some extra security to hold it on there. You don't need to really cinch it down or anything. And I'm going to try to miss these lights too, because this is how you know what channel you're on if you look in there. It's going to kind of stink having it upside down, but I can still see it if I look at it from behind. It's still not obstructed too badly. So the nice thing about the Screech is it does come with these 3D printed parts. It actually comes with a 3D printed camera mount as well. Just in the box, it's not an option or anything like that. It just comes with it. which is really cool. It also comes with a 3D printed GoPro mount for the front, but I do not have my Hero 5 session any longer, which is unfortunate. That was the best GoPro, so I have a big honkin' GoPro that I have to put on here. But the 3D printed parts are nice, because that just goes right in here, and then it puts it nicely in between these two. All right, yeah, so that's going to work for sure. Okay, so I'm going to pop that off at the little MMCX connector on the back there, and I'm going to pop that off here at the wire harness, just so I can set that aside now that I know that that VTX is going to be nice and stay in place there. Give a little bit extra pressure. So I took this wiring harness off of another build that had an OSD. So my, like I said, this one doesn't have an OSD, so I do not need the brake in this video wire. So the yellow is usually your video wire. Don't use that Gorilla Glue. Yeah. Oh yeah, it'll pull off. Don't use the Gorilla Glue without heat shrink, or if you do, I've definitely done that before. So there is, like I was saying, a layer of heat shrink on here for sure, because the Gorilla Tape will pull off components of your circuit board. It is that strong. Not a sponsor. You'll notice this wire right here, this yellow wire. It's cut right here between my camera and the VTX because I was using it with a board that had an OSD, which you have to put the camera into the in on the OSD and then out. So I'm going to need to actually butt solder this. And I about did that before this stream, but I thought it might be a good opportunity to do a butt solder on stream. For those of you who are not familiar with the ways of the soldering, so I'll punch in a little bit here. So I've got my little helper that I like to use. Got two little alligator clips. That is really nice for jobs like these with really small wires and parts that you need an extra helping hand. I'll go ahead and get that set up. And got a little box of heat shrink here. Get a small bit of heat shrink out. And in order to conserve some of this heat shrink, I'm actually going to cut it in half because I don't need this whole tube of heat shrink. So I'm just going to nip that right in half. I could probably do even less, actually. So I'm going to nip that right there. Get my heat shrink staged on the wire before you solder it. That's a big one. I always do that. I'll solder something together and go, okay, now time for heat shrink. Guess what? Can't put heat shrink on after you've soldered. So I've got my iron warmed up. I'm going to get my flux out here and just dab a little bit of flux on each wire here to kind of help the solder flow into it. And then get my iron and some solder. And just like we did with the flight controller, we're going to just tin these a little bit. They might have some solder on them already, but I'm just going to make sure. So just get a little bit of solder on there. Oops. So they're tinned, so they've got just a little bit of solder going on. And we're going to just put them together, just side by side, and do the same thing. Just get a little solder on there so it flows over both. There we go. So it flows both over both wires. So that should be a good connection right there on your solder. Easy as that, and that's how you do a butt solder. So we'll get you zoomed back out here. I'm going to pull over my piece of heat shrink that I had staged. Now you can use a lighter or something. I've got this little industrial hair dryer that I use to heat shrink. And there you've got a good connection butt solder. And to test that, something that everybody needs on the bench is a good or a cheap multimeter. And what I'm going to do is just set this to, I have it already set to measure resistance. And so if there's a short, the resistance is 0. So that's a good way to detect shorts in your build. And I'll do this definitely before I plug in the battery, because if you have a short in your build, things catch on fire very easily. So I'm just going to put one prong of my multimeter on that end and one on the other end. And good, yes. So you see here it's reading 0. So we have good connection there. So we made a good connection. It's just a little trick on how I test for continuity using impedance on your multimeter. So we're going to put this away, keep my workbench tidy. So that should be all set up to go. We've got your power and ground here. And I believe that the Cricket, I'm going to need another zip tie there. I believe that the Cricket can accept pretty much any voltage on here. I'm going to pull up this wiring chart here so I can double check here. 5-volt output, that's nice to have, then ground, then video. So my orange wire is 5 volt, white wire is ground. That is not right. So I'll need to make sure this is, so you got to double check your wiring, guys. I know this is some pretty dry stuff, but this is how we do things. Smart audio, I'm not going to need that. I can take that out. And then ground and 7 to 28 volts. So yeah, that's definitely what we'll need. So what I'm going to do is I'm going to remove that white wire. I don't know how or why that got in there. Take my tweezers. Are you building it without the OSD to the flight controller video direct from the cam to the VTX? Yes, James asks that question because this flight controller that I'm using is a Revolt version 2, and that is before they had OSD built in. So this is a non-OSD flight controller, doesn't have it built in. I usually prefer Betaflight OSD flight controllers. Those are really nice. I have flashed Betaflight onto this board since RaceFlight is now kind of defunct. But I always like to have an OSD, and this camera provides a voltage output on it because I like to monitor my voltage on my battery at the very least. The other things are nice for Betaflight OSD is as far as tuning and stuff like that goes. But this is just the flight controller I had laying around, and it does not have an OSD. So good question. That is why this used to be broken, because it used to be on an OSD flight controller. Now it's not. So I'm going to remove this white wire here because I don't need it, and I like to keep a clean build, and I don't like to just cut them off because I can use them later. So I'm going to get in here with my tweezers and just pick up that little prong. See if we can get in here close for you guys so you can see what I'm doing. So you just pick up this little prong here with your tweezer, and then that pulls right out. And if you want to keep those nice, you kind of push that back down in there. So next time you go putting something in there, it'll stay. And then smart audio.
Wicked smart.
I'm not going to be using smart audio in this build, which is this green wire. So we're going to take out smart audio. That up and just pull it out. All right. So that should be good. You've got 5 volts going to the camera, I believe. I'm going to double check that this isn't going to fry my camera. VCC. So 5 volts will be plenty for that. But that should at least give me the connection from the VTX to the camera. And what I'm going to do here, I'm just going to play it safe and see. So VBAT and ground here is where I'm going to be tacking my VTX power to. And I'm going to do it underneath, again, because I like a nice clean build. So what I'm going to do is just have this, use my flight controller stack as kind of a nice holder there. So you've got your VBAT and your ground. So VBAT means you're getting full current. There's also a 5-volt BEC in case you needed to get 5 volts from somewhere, and then your ground. So we're going to just get a little bit of flux here on our tip of our solder so we can put it on those 2 terminals. And that's going to help the flux flow onto there once we apply heat. And just like our ESCs last time, if you guys weren't here last time, I said that you just need to make sure you get in there with the hot iron and get out. And I've got my iron set to about 730 degrees Fahrenheit, which is about 390 degrees Celsius is what I usually set my iron to. A little bit higher if it's like a ground circuit that needs a lot more heat. So we'll just get in there, once it gets nice and hot, touch your solder to it. Oh, come on, get on there, buddy. And it's just going to flow real nice onto that pad. So that was the ground. So that took a little bit more heat. And then we're going to do the same to VBAT, which is not going to take as much heat. Get in there, heat it up, touch your solder to the pad, and get that nice little blob of solder. The shinier the better when you're soldering. A good shiny connection means that you have a good connection most of the time. So we got that. Let's go ahead and I'm going to tin these wires here. See if I can get that in view while I'm tinning. Get my helping hands over here to hold those still. Again, I'm just going to kind of touch the flux on these guys, just get a little bit of flux on there. And actually, I've got a little bit of solder on my iron still, so I can kind of come in here and just tin them with that solder, and that's kind of stuck to my iron. And then clean my iron. All right, now let's get that off of there. Now I'm going to go ahead and solder up the power. Double, triple check that you do not mix up these wires. I don't know how many times I've done something dumb and you're just soldering along, you're going good, and for some reason, muscle memory or whatever, you solder the power wire to a ground or ground wire to a power, and you just mess up the whole thing. And that's not good, because that's what causes damage to components. So double check. Even if you thought you checked, check again. So there, that's a good connection. And then when I put the board on the way I intend, we can run that power cable underneath. So it kind of hides it when it's running under the board like that. That'll make it look real nice, and of course excuse the other wires that are just kind of flopping around here. That's going to make that build nice and clean. And I'm going to take that off again. And while we're at it, I'm just going to take this off. Twist these wires up so they stay nice and clean. I'm also going to twist these wires up, just kind of form a braid. And we've got a little extra on the yellow, which is going to bother me. Not going to lie, that's going to bother the heck out of me. But it'll work. It'll be okay. I'll just ignore it. And so we'll run that also underneath the flight controller, just in the interest of keeping it nice and clean. And that should be just long enough to come out to our camera. But anyway, we're going with this. We're probably on track to be able to test the video system here. Hopefully, that would be cool. So I'm going to go ahead and get the camera all mounted up. And one thing about this frame is since it's kind of a low boy, it's got that little cutout so that the camera can actually do some good tilt, which is kind of neat. A lot of times with these kind of frames, you have to get a micro-sized or a small, very small camera to use on here. But this is a nice thought-out design so that camera can just kind of low boy it right in there. I might need some smaller screws, actually. Those are kind of long. Those aren't wanting to tighten up. So I'll go ahead and connect my camera up. Connect my flight controller back again since I unhooked that. I'm going to go ahead and solder on the main leads here too so we can test this video system out. They included a lead actually, which is very nice of them. So I don't even need to mess with that because they gave me one. I don't know, I was kind of thinking about making a short one though. Let's make it the length of our capacitor so I can shrink wrap the capacitor in there. Have that all nice and put together, because that's going to be cool. Cut off those leads. That is some thick wire. Strip off just the end here. Go ahead and get some flux on these leads here and tin up my leads. I've already tinned up the pads. Sometimes I cheat. I stick the solder on the iron. I know that's not what you're supposed to do, but sometimes you just need that little touch of heat to get them started. So I'm going to go ahead and solder these on. And check real closely here. This is the positive side and that's the negative side. Positive, negative, because this is the big one. If you mess this one up, not good. So I'm just going to solder it straight down perpendicular like that. Little hacky. Not too bad. All right, now putting the capacitor on here. Because I think I cut those too short. Anyway, that's on there for now, so we can test our video system, because I know you guys are just waiting to see that. Before I plug a battery into this, though, I'm going to take my multimeter. I'm going to have it on the impedance test. We're going to see, hopefully we don't this time get continuity if we check our positive and our negative, and we don't. So that is a good sign. That means we do not have any shorts in the system. I'm going to go ahead and connect the VTX, see if that introduces any kind of shorts or anything like that. Just double check here. Good. So that is a good sign. Another way to check that is having a little device called a smoke stopper. So that's taken by wiring up a automotive headlight bulb kind of in between the battery and the drone. And basically, if something were to happen, this is going to light up and hopefully pop before the current makes it, kind of limits the current, so all the current doesn't make it to the drone and burn something up. So let's go ahead and get this antenna on here, and hopefully if I start this up, we'll see some FPV video. Turn on the FPV feed here. All right, good battery. Wish me luck, guys. Moment of truth. Let's see if this happens. Worst case scenario, we get some smoke and you all can laugh at me. Hey, that's a good idea. Okay, let's turn on our VTX. Hey, look at that. Check that out. That's not coming through. Why not just use a fuse? You can do that. Some smoke stoppers do that. But this lets you know real quick. Because if you plug it in and the light bulb lights up, it's a lot better visual cue that you can get, because it doesn't stop it all the time. Sometimes you plug it in, the light bulb goes up, and you still get smoke. So the light bulb kind of tells you, hey, unplug now. So that's a really quick visual cue. So I'm going to plug it directly in here. I'm not getting that second set of beeps, which means I'm not sure. The FC and the ESC aren't talking. So that'll be something to troubleshoot. But for right now, we do have FPV signal, which is what we wanted. So I went ahead and took a look at my pinout for both the rSXR. This is a FrSky rSXR receiver. I have a lot of good luck with these. I like these, and I like the R9 minis as well. I find that the R9 minis actually have a little bit better connection because they're meant for long range. So when you're flying, in a park or something like that, they stay pegged at like 99% RSSI, which is really, really cool. But we're using an RSXR for this one, and I haven't had any problems with those. I just prefer the R9 minis. But first of all, go ahead and pull up my pinout for the RSXR. We have 4 wires here. One of them is a S port, which I don't need. So this yellow one is going to be S port. So I'm going to go ahead and take that out. If we look at the pinout for the RaceFlight stack, if you look over towards the lower right quadrant, you'll see where it says S-Bus +5 and ground on the TX4 pads. Those would, if we flip it over and we look at my overhead shot, those would correspond to these pads here. So we'll go ahead and flip that back on just so I can double check. So at the top, the second pin looks like it's going to be, and that's actually TX1, I'm sorry. That's actually going to be S-Bus. So we'll go S-Bus, then power, then ground. So this green wire is going to be our S-Bus wire. And we'll just go ahead and, these are already tinned because they've been used, so there's a little bit of solder on there, but we'll put a little bit of flux just right on the tip of there and start to solder. So we'll do S-Bus on that second pad right here. So that's already nice and tacked on there. What I like to do is kind of twist these up just to clean up the wires a little bit. So we'll twist them, give them kind of a braid. Twist those, twist those, twist those. And then we will take our receiver here. We'll go ahead and plug that in. Oops. Try not to take off these little antenna. These little mini UFL connectors are tricky. They like to come off. So where I think I'm going to put that is just right there. And what I'm going to do before I just do a quick little test fit right there, and that's going to fit super nice right there. And then I'm going to go ahead and grab some shrink wrap this guy down. All right, so that's going to help those antennas stay on, and that's going to protect some of the components from this Gorilla Tape that we're about to use. Let that cool down a little bit. Don't want to burn off my fingertips. So I've already got, so what I said earlier, I don't like to waste anything. I've got a little piece of Gorilla Tape here that I've used. I got some other stuff up and ready, and I cut off the whole strip, and I only needed about that much, so I just stuck it right there. So I'm going to use this that I've already kind of saved. Just stick it on the back of this guy here, and it's actually perfect for that. I must have used it on another rSXR, because that just fits perfect. Go ahead and plug that in so I know I can get the clearance with the connector. Pull off the back, expose that tape, and then we'll just push her down right there where we fit her into. I'll make it a little offset so it doesn't interfere with that. So there's a lot of good areas to do that. So I'll just put my zip tie in here, and we'll zip tie this guy down. I'm not going to go too tight on this, just enough to kind of keep it in place. I don't want to break the circuit board or anything like that, of course. But there we go. And then we'll get my little nippers out here and just nip that right in the bud. There we go. All right, so now it comes to what to do with these little guys here. Usually you hear that they've got to be at 45-degree angles, and usually the best way to do it is one pointing up. Let's see here. One pointing up and one pointing out like that at 45. I've seen, since we're not trying to get, the most distance or anything out of these little receivers, I usually, when I tape down my motor wires, I usually leave my zip ties here. You can see I've zip tied down my motor wires, and I usually leave some slack there to kind of tack my my antenna wires down to, and that's a good, or a 90-degree angle. I think I said 45 earlier. That's a good 90-degree angle there to keep them up out of the way. It keeps them out of the propellers. But the thing about this frame is it comes with this 3D printed piece and these antenna tubes. And the way I have that set up, I might just be better off using those antenna tubes. I don't usually like having anything hanging off the back, but I think I'm going to do it this way, actually. I planned to go this way. I wanted to leave that there, but I went ahead and left them on just to share that tip with you guys, that if you don't have something like this, you can just leave a couple of these. And what I do is I route them down, each one down here, well, real nice. And then I put a little piece of shrink wrap over this antenna and its zip tie there. I'm going to go ahead and clip those though, because I'm not going to use them. Just a tip for you guys that I wanted to share about how I do that sometimes. But this is just so nice and perfect with their little antenna tubes here. I feel bad not using them. So I'll go ahead and run that down there. A little bit of the antenna sticking out. And I'll run this one down this channel. All right, so there we go. Receiver's mounted, and this is a completed quad. But what I'm going to do now is grab my data cable I've got here, and let's go ahead and plug this up to Betaflight. So I've got my Betaflight. Here, we'll do this one. Got Betaflight here, all ready to go. And I kind of messed up because my mains are in the way of my USB, so I gotta finagle it a little bit, and that's gonna come back to haunt me probably when I'm trying to hook this up and tune it. But there we go. So we should have connection. Yep, you can see there in the upper right near the connection options, you've got connection to COM port 3. Now, there's a little bit of setup to Betaflight. A lot of stuff can be solved by downloading these drivers here. If you can see my mouse, you've got the various drivers, and they've got links right here. So you definitely want to make sure to read the directions on those, set them all up, because one of the things for this build specifically was you had to put this board in DFU mode, which allows you to access the bootloader and write software to it. So JSL numbers, that might be something that you want to double check with if you're looking at connection flashing issues, is to definitely make sure your drivers are updated. Yes, drivers. And what I went through all of these that they had, and one thing that I had to do that was different was Impulse RC has a driver fixer tool, and none of those on that list worked for me here. So I had to download the Impulse RC driver fixer tool. You can just Google that if you need it. It should be one of the things to look up into, but I used that and it fixed my problem right away. So definitely make sure your drivers are all up to date. Perfect. Matt's got a link down there. Great catch on that one. And I think it's the second option. If you download the first option, it's some bit of software, but it's the second option. Want the driver fixer. So make sure that you go there. But we already have this set up, so I'm going to go ahead and connect into Betaflight, and we're going to plug in. First of all, I guess I should probably show you guys exactly what I did here. I'm going to have to zoom way in to show you this little hack that I had to do. So I am using RaceFlight, but I flashed Betaflight to the board, which made me have to, let's see if I can get this board flipped over. So you can see here, I've got this little jumper. Let's see if I can zoom in even more. I've got this little jumper that I had to put in there, and for some reason, that is what ended up making my receiver work. So I don't know what was going on, but I had it all set up right as far as wiring and software goes, but for some reason I had to put that little jumper there. I don't understand it. I'm not going to pretend to. Found it on the internet. Some guy said, hey, I tried this and it worked. And then I tried it and it worked. So that's what was going on with the receiver. It's kind of a weird technical problem, but if you do try to follow this guide as how to build a drone, again, this isn't a definitive guide on how to build every drone with every component. These are just a handful of components that I had laying around, and I'm just kind of building what I have. So we'll go ahead and connect here in Betaflight. And one of the first things you want to check, well, I don't have my accelerometer on, but we'll go ahead and turn the accelerometer on, and we'll just check the positioning of this board just to make sure that we are correct. So what you want to do is just kind of play with the quad And of course, mine's kind of facing towards me and that's facing away, but I'm nosing down and the quad is nosing down, nosing up, it's nosing up. And then the roll axis seems to be right, as well as yaw, which is something you definitely want to make sure those are all, you know, correctly configuring. So that's kind of easy because my board is oriented the correct direction. As you can see here, the arrow, there's usually an arrow on the flight controller that points to the front of the craft that is oriented correctly. So that is why it is going in there correctly. So we'll go back to Betaflight though. And since that is done, I usually, like I said, don't turn on my accelerometer because that's just extra computer power, which my CPU load down here is 11%. So it's actually not taking up too much of it, but just as a general rule of thumb, that's how I like to set up my quads. So we'll go back in here, do it one by one. So again, this is how I'm set up here. So this is my receiver on UR1. It is a serial receiver, so I do have that serial tab checked. So that was all correct from the previous episode. Again, it's just that little jumper that kind of made things difficult. This is an X configuration, and my motor direction is reversed. So as you can see here, usually motors spin towards the FPV camera. So if you're looking at my overhead, the motors would spin this way. So the propellers would go in towards the FPV camera. I like to run reverse direction, which you'll have to select this, in which case the propellers rotate from out of the camera. And one of the major reasons why I do that is if you're going headfirst into a tree, if you're running motors in, it likes to grab that branch and bring the quad into the branch. If you're running motors out, it has a tendency to bounce off of it. We don't need a craft name because I don't have Betaflight OSD. Again, serial-based receiver, S-bus is what we want. Air mode, anti-gravity dynamic filter is all on by default. If you want to know what those are, definitely go ask a more experienced guy like Joshua Bardwell, because he has 5 videos probably on each of those settings. But like I said, this is just how I set up my quads. I don't have a beeper, so I'm not going to mess with any of that. D-Shot 600 is the protocol I like to run. And because we are on Betaflight, usually with RaceFlight, you want to run that on multi-shot, I believe is the one that they prefer. But I think technically, since this board is Betaflight, that doesn't matter, but that's what I'm going to keep it on. So we'll just save that. I did make changes. I did do motor direction. So we'll want to save our changes there. We'll go down to the next, PID tuning. So I'm going to leave this all as default right now. One, because I have to kind of read up on this because this is Betaflight 4, and I am not 100% on Betaflight 4, but it should work pretty darn good out of the box from what I've heard. We shouldn't have to tune too much. If I find that we have some vibrations or tuning stuff, we can come visit that in another episode once I've got it flying. Receiver. So I'm going to go ahead and get out my radio here.
Welcome to OpenTX.
And everybody who knows that, who has a FrSky radio with OpenTX knows that sound. So I'm going to go ahead and turn this guy on here. And we should, look at that, we should begin to see where it is actually communicating this time. So it looks like everything is working correctly. Pitch, yaw is working correctly. Throttle, you can see, is getting some signal there. Auxiliary, we're going to have to change our auxiliary from how I had it set up. And then I have RSSI going to channel 12. So let's look at our modes again. Last time I was telling you about my arm switch, so I have this set to auto. So if I flip a switch, it's going to automatically show that auxiliary 1 is what I want. So that's going to be, let's see if that's in focus at all. That's going to be this switch here for arm. That's what I like to use. And then I also like, and we'll move that so that when it's activated, it's within this active range here. And when it's deactivated, it is not. Another thing I like to do is use pre-arm. So we'll do auto and this momentary switch here is my pre-arm that I like to use. So we'll go ahead and do that there. Make sure to set it to the range where it's on. So what pre-arm is, for those of you who are not familiar, is if my quad was all plugged in now and I, for some reason, accidentally hit the arm switch, if I didn't have a pre-arm, my quad would be armed. So sometimes, you know, you're walking through the field or something like that, and you've got your radio with you, and you accidentally bump your leg or something like that, and you flip the arm switch. That's, you know, if you're holding your quad, that's no bueno, because you're going to get a finger chopped. So that's just kind of a fail-safe. You know, you have to be on this momentary switch and arming to actually arm your quad. So that's just an extra layer of safety that I like to do. Otherwise, flip over after crash. So turtle mode, I like to set that on this switch here all the way down. Again, these are just personal preferences, what I've come to like, and we'll save that because that's all we're doing on that tab. And I will show you something really cool that I like to do with this switch here. This is a 3-position switch, and I like to actually put my rate profiles on here. Sometimes I like to fly real low, slow and smooth, and have like real nice, you know, cinematic movements. But other times I just like this flip, the snap rolls and the quick flips. So I have the smoothest setting at the top of the switch, and then kind of in between snappy and smooth, and then all the way down is a snappy tune. And I will show you how to set that up right now in Betaflight. So what you'll want to do is enable expert mode. I want to make sure I save that again. I think I did. So you'll enable expert mode, and you'll go into adjustments here. So we'll do auto. Oh, actually, that's going to be auxiliary 2. Nope. Try again. Auxiliary, what is this? 3. All right, so you can see here, this is that little switch again here. So you can see here, that's enabled there, and you want this to cover the full range. So you can see it's in every bit here. And then you'll want to apply, where is it here? Rate profile selection right here. And then via channel auxiliary 3. So what that is going to do, I'll save that, and then I'll go back to my PID tuning tab. What that's going to do is enable you to select these rate profiles. So you can see here, as I'm flipping the switch through 1, 2, and 3, my rate profile is changing. So I can take rates. So on 1, we'll do 70. Okay. On 2, we'll do 75. And of course, I'm going to tune this back to my liking for each of these here, because I think yaw usually I go a little bit lower. And then 3, we'll save that. And we'll flip over to 3, and that'll be 80. There we go. And right now what I'm going to do is go ahead and check the motors out. So I just want to make sure my motors are all spinning the correct way and are on the correct pads, because I had to flip the ESC around a little bit so that the mains were sticking out this side. So we want to make sure that this is motor 1, 2, 3, 4, and I always go props out so that they spin against each other away from the camera. So that's what I'm going to set up for here. So what you're going to do is go ahead and apply power to your quad. You get all the startup tones, and then props off on the bench. This is that switch that says I do not have my props on, because this is going to make these motors spin. So never, ever, 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 ever have your props on when you're on the bench. Always take them off. It takes 5 minutes and you save all your fingers. Never, never, never have your props on the bench. That's like rule number 1. So we're going to turn that on, saying that we don't have props on. And then what I do is just do a spin up of all of them, just to make sure they're all spinning. And it does look like it. And I'm going to take it real low So I apologize if you guys just hear motor noise, but I'm going to turn the motors down real low, and I'm just going to take my finger, or you can take like a zip tie or something to test the direction. So what I'm going to do is take this piece of zip tie I've left over and just kind of check the motors. So this motor is definitely spinning this way, which is what we want it to do. This motor is spinning the wrong way. It's spinning this way, which is not correct. This motor is spinning the right way. So you can see here, I'll try to zoom in so you guys can see that here. I don't know if you'll be able to see it, but you can see the zip tie showing the rotation going this way. And then the last one is going the wrong way. So I'm going to cut those off. So it looks like these two motors here are the ones that we're going to want to reverse, which we will do in BLHeli suite. So that's another program you got to download to program the ESC. Or you could swap motor wires, but I don't like doing that. First of all, we hid the motor wires, so it's not an easy swap for us. So we're just going to do it in software. But to move on, I'm going to just make sure that we're going with motors 1, 2, 3, 4. So you can see right here, that's what your motor setup is for Betaflight. You can do custom motor orders and stuff like that, but I don't know why you'd want to do that. So what we're going to do is just spin up one by one. Okay, so that is the wrong motor. 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 All right, so that is another thing that we have to do in Betaflight. So again, this should be 1, 2, 3, 4, and it looks like we went 1, 2, 3, 4. So we're kind of flipped around. So let me double check that again. 1, 2, 3, 4. Okay, 1, 2, 3, 4. And what we're going to have to do is get into our CLI, which is going to reboot our board. In your CLI, you're going to put in, if you have to do something like this, usually they set up right, but I had to get fancy with this board and flip it around and turn it. So I'm going to type in the resource. All right. So we got to make note of where these motors are. So we've got motor 1 on B00, motor 2 on B01, motor 3 on A03, motor 4 on A02. What I'm going to do is I'm just going to write this down. Motor 1, B00, motor 2 is B01, motor 3 is A03. So these numbers are just telling the chip, which one of these wires to fire the motor signals on. And we want to make sure that these are on the correct channels, because if you have them all wonky, then the software is going to tell the flight controller to tell the speed controller to speed up motor 1. But if motor 1's over here on another motor, then it's not going to know which way is up, literally. So we've got motor 1 and motor 2. So basically we need to flip motor 1 and motor 2. And the way we do that is resource motor 1, and I want none. So we're going to clear motor 1 and motor 2. Resource motor 2, none. All right. So now these are clear. So what we're going to go do is rewrite where the motor is. So we'll go resource motor 1, and we want to tell it to use what used to be motor 2. So we want resource motor 1 B01. Okay, and then we want resource motor 2 to be what motor 1 used to be. So that'll be B00. There we go. And then we'll save, and we'll double check that. So now when we get it all back up, these two motors should now be hopefully in the correct spot. So let's go back to our motor tab. I understand I do not have my props on. Spin up motor 1 should be this one. Yes. Spin up motor 2 should be this one. Yes. And are those, they're actually going in the right direction now too. Nope, this one needs reverse still. This one still needs reversed. Okay. Good. Now we'll go back and we'll just flip around 3 and 4. So resource 3 and 4 is A03 and A02 respectively. So we'll go resource motor 3, none. Resource motor 4, none. And then resource motor 3, which will be A02. Oops. Make sure you got a space in there. And then resource motor 4, A03. And save. And you can see up there, motor 1 is B01, motor 2 is B00. Those used to be flipped. So you can tell that they definitely has flipped. So we'll save that. It's going to reboot. We'll connect back in there, go back to the motors tab. And now this should be motor 3. Yep. And this should be motor 4. Yep. Motor 4 is going the right way. Motor 3 is going the wrong way. So now what I'll do is I'll go back into BLHeli and get them rotating the correct direction. So we've got BLHeli. Make sure that we're disconnected from Betaflight because you can't use more than one COM port at a time. Connect here, and we're going to read setup. Now you have to be plugged in to read your setup. And what I'm going to go ahead and do is while we're in here, let's flash all to the newest version of BLHeli. So that just updates the firmware of the ESC to make sure that you are on the most current one. So we'll do ESC2 is reversed, and then 1, 2, 3, ESC3 is reversed. So that should change the direction, hopefully to the correct direction. And we'll write that setup. Going to disconnect here. And then we'll go back into Betaflight and we'll test our motors. So now motor 2, okay, is spinning the correct direction. So it's spinning this way. And motor 3 is also spinning the correct direction. So there you have it. We do have all of our motors set up correctly in Betaflight and updated ESC in BLHeli. I think I'm ready to plug it in and make sure everything's working right. So I'm going to get out of Betaflight here for a moment. Put this off to the side. I'm going to keep it on because I'm going to plug in a battery here. Props off on the bench. I'm going to plug this in and we're going to test her out. So that first set of beeps says we have power, and then usually there's another set of beeps. You know what? I don't think I have 5 volts running to my flight controller. That would be the problem, wouldn't it? So let's see what all we have power to, because I don't think the flight controller has power. We know, well, we don't know that the receiver has power. This definitely has power. And this has a 5 volt out, which I think I could tack onto my flight controller here. I almost kind of think we have a toasted 5 volt regulator here, which would be this guy. But let's see here. I'm going to pull up my Cricket because I know there's a 5 volt coming off of that. And it is this orange wire going to the camera. So here's what I'm going to do. That's getting power. That has a good 5-volt out. I'm just going to cut that wire, and that's I know exactly what I'm going to do. All right, so this orange wire here going from my VTX to my camera, that's what's giving 5 volts from the VTX to the camera. So I know that's a good 5-volt line, and I know that's what's going on. So I'm going to cut that, and I'm going to just run it through my flight controller and see if that works. Because I have 2 5-volt pads that are connected. So I'm just going to use this 5-volt regulator on the VTX to try to power the flight controller. Let's see if that works.
It's a bold strategy, Cotton. Let's see if it pays off for him.
Get that stripped back. Get some flux on it. So let's run through the board. So that's 5-volt here. We'll get this. Sorry guys, I'll try to get this going. I'd be really cool if I could do a hover test for you today, because that's where I really wanted to be. 5 volts there, and then we will tack the camera on there. Hopefully get the 5 volts that's running through here once we connect the VTX 5-volt out to the other 5-volt pad on this board. I'm going to do a test here real quick. So here we go. So no continuity, which is a good news. So let's plug this in and see if we get a signal. Yes, it worked. Check that out. All right. Yeah. So now I'm going to turn on the radio, and we'll see if we can get these motors to spin. So I'm going to get some of this stuff out of the way here, and let's see if we get some spinning here. So I've got my radio all connected and ready to go. Look at that. All right, cool. Awesome. So radio talking to quad. All right. I think I'm going to bolt these all down, and we're going to run outside and try to hover real quick, because I think we can get that in. So let's do that. So I'm going to unplug this and get this all bolted down. I'm excited. That's really cool. So I'm going to mute myself here. So I'm going to cut out my audio for a second, and then I'm going to jump on my phone, put on some propellers, because that is definitely needed for a hover test, for sure. I've got these nice V1S HQ props, 5x4.8 by 3. All right, props. Let's go back down. Let's try this again, shall we? There you go, good enough. I always do a prop spin check. Props are spinning, we're good to go. Hover test is good. Got it. Just going to leave that there and come back later. Again, thank you guys for hanging out with me. I'm glad we did get a hover test. I'm sorry we went a little bit over an hour. I like to keep them that short, but we'll see you next time for, I don't know, some flight videos, some PID tuning. We'll figure it out. Thanks again, guys. All right, hey, how's it going? We are out here at Site 1, and I've got, we're doing a social distancing situation. I got my spotter Kyle out here with me, and I thought it might be a good time to get that quad that we just built. And again, it's the ReadymadeRC Strix Screech frame. Built this off as you just saw, so we're gonna give it some flying lessons, see how well it flies. So I apologize, this is going to be a FPV feed because I do not have a GoPro mount for this frame. The only GoPro mount that they provided was for a session, and unfortunately my session is no longer with us. But so enjoy the FPV feed, and we'll see you. You just saw the first actual flight on the ReadymadeRC Screech build that we just bought here, and I mean it did pretty darn well. You know, there's a couple spots where there was some prop wash, but that was all default settings. I had considered doing a tuning video, but I don't even know that that's necessary because Betaflight just seems to be so good right now. I think we're on Betaflight 4.4. So I'm not even going to tune that. I'm just going to let you watch that footage and guess for yourself how well it flies. So All right, thanks for sticking around. Make sure if you're not an AMA member, go ahead and go to modelaircraft.org/join. We have a lot of fun around here. You know, you get that insurance and everything, so it's really cool. But be an AMA member. Join us on Facebook, iFlyAMA, hashtag iFlyAMA. It's a great group. I'll be posting to this group. So, hey, iFlyAMA guys, special shout out for you guys. But join us on that group, join that conversation, follow us on Instagram at AMA Model Aviation, and I'll see you on the next one. Thanks a lot, guys.